Factoring special cases. Today's lesson will be about 3 special cases in which you can factor much more quickly once you know the shortcut. For each case, I will show you the long way first to review how you do it the long way, but also give you a shortcut. In the first case, you notice that you have a quadratic trinomial where the leading coefficient is 1. So we multiply 1 times 3 to get 3. The factors of 3 are 1 and 3. So our normal way, we would write this out: x squared plus 1x plus 3x plus 3. Now factor by grouping. The final answer for this one would be x plus 1 times x plus 3. This is the way you already know, but notice the factors 1 and 3 show up in the answer, so I could jump to the answer. If I notice that the leading coefficient is 1, I can do a shortcut. It goes like this. Put the x at the beginning of each parentheses, and now find the factors of 3, the last term. So the shortcut is very simple if I can remember it. If the leading coefficient is 1, then I find the factors of the constant that add up to the middle term, and I place them directly into the answer. Let's try the next shortcut. The next shortcut is for factoring difference of squares. From when you multiplied difference of squares, you can remember that it would be 2 factors, one with a plus in between and one with a minus, but with the same terms. So we are going to do this first the long way, and then I'll show you the shortcut, but you may be able to guess the shortcut already. So I'm going to stretch this out. X squared plus 0x minus 81. And I'm going to do the long way. 1 times negative 81 is negative 81. I need 2 factors of negative 81 that will add to a 0. So they need to be opposites. So 9 and negative 9 will add to 0 but multiply to negative 81. Now I write my 4 terms. X squared plus 9x minus 9x minus 81. Factor by grouping. The answer is x plus 9 times x minus 9, which is what we would expect since we got a difference of squares. And notice how easily we could have guessed this. We could take the square root of the first term and put it in the beginning, and the square root of the second term and put it in the end, as soon as we saw that we had a difference of squares, then a plus and a minus in the 2 factors. So when you want to use the shortcut for difference of squares, take the square root of the first term and put it in the beginning, take the square root of the last term and put it in the end of each factor, double check that you have a minus in between, a difference of squares, which means it'll be a plus and a minus, and you have your answer. Pause the video now and try it yourself. Now that you've tried it yourself, check your work. I will show the long way and the shortcut. First, 9x squared plus 0x minus 16. I multiply the first term times the last term for negative 144. I need 2 factors that multiply to a negative but add to 0. I notice that 12 and negative 12 multiply to negative 144 but add to 0. 9x squared plus 12x minus 12x minus 16. Now factor by grouping. The final answer is 3x plus 4 times 3x minus 4. We could have guessed this by using the shortcut. The square root of 9x squared is 3x, so I put 3x at the beginning. The square root of 16 is 4, so I put a 4 at the end of each. Now I put a plus in one of the factors and a minus in the other, and I have my solution. The last example in this case does not look like it is our special case. 50 is not a perfect square, nor is 32. But I notice that they're both divisible by 2, so I try factoring out a greatest common factor, and I get 2 times 25x squared minus 16. Now I have my special case. Instead of once again doing it the long way, we'll go straight to the shortcut. I need the 2 at the beginning. Now I'll do the shortcut for the difference of squares. The square root of 25x squared is 5x. The square root of 16 is 4. Now I put a plus in one of my factors and a minus in the other. And I have my solution. That is the shortcut for difference of squares. Our last special case is factoring perfect square trinomials. You'll remember in multiplying, we squared a number, it would end up with a perfect square at the beginning, a perfect square at the end, and the middle term would be double the product of the two terms inside the factor. So to recognize this going backwards, we need to notice a perfect square at the beginning, a perfect square at the end, and then the middle should be double of the product of the square roots of these two terms. This is fairly difficult to recognize, so it'd be a good idea to also know how to do it the long way. 1 times 81 is 81. Two factors that multiply to positive 81 but add to negative 18 are negative 9 and negative 9. Negative 9 times negative 9 is positive 81. Negative 9 plus negative 9 is negative 18. Now write it out. X squared minus 9x minus 9x plus 81. Factor by grouping. Notice that my answer comes out to x minus 9 times x minus 9. We usually write this as x minus 9 squared, a perfect square trinomial. In order to use the shortcut, I need to recognize the pattern. So I notice that x, the first term, is x squared. I also notice that the last term is 9 squared. I need to look at these square roots. 9 and x go into the middle term and multiply it by 2. That would be 18x. The middle term is double the product of the two square roots, so this follows my pattern. The shortcut then is to do this. Take the square root of the first term, take the square root of the last term, look at the sign between the first and the second terms. It's a minus, so put a minus. And my answer is x minus 9 squared. This only works if it fits the pattern. Look for the perfect square at the beginning, the perfect square at the end, then see if the middle is double the product of the square roots of the other two terms. Pause the video now and try this one yourself. Now that you have tried it, check your work. I will first do it the long way. 9 times 16 is 144. Two factors that multiply to 144 but add to 24 are 12 and 12. 9x squared plus 12x plus 12x plus 16. Factor by grouping. My answer is 3x plus 4 times 3x plus 4, usually written as 3x plus 4 squared. To use the shortcut, I needed to check whether it fit the pattern. The first term is a perfect square. The last term is a perfect square. So I need to check if the middle term is double the product of these two terms. 2 times 4 is 8, times 3 is 24. 24x. The middle term is 24x, so I can use my shortcut. The square root of the first term is 3x. The square root of the last term is 4. The sign between the first two terms is plus. And I have my answer, much quicker if I can recognize the pattern. Once again, the final example does not look like our pattern. It's disguised. Those of you that have the printed notes will need to correct this final example. There was a different problem given here. So the first term is not a perfect square, the last term is not a perfect square. But I do notice that there's a common factor. I factor out 2 and I get 25x squared minus 40x plus 16. Now this looks like it might fit my pattern. The first term is 5x squared, so I will just check. 5x squared is 25. I look at my last term, it's 4 squared is 16. So I need to check my middle term. 5x times 4 is 20 times 2 is 40x. My middle term is 40, so it does fit my pattern. Instead of doing all the work I did before, I'm just going to fill in the square root of 25x and the square root of 16, and then I look at the sign between the first and second terms. It's a minus. And I've finished factoring. So we've practiced the shortcuts for 3 different special cases. Before you finish, there's one warning. Beware of these expressions. They are unfactorable. This is not a difference of squares because there's a plus in between. 2 perfect squares with a plus in between is not factorable. In both cases, these are not factorable. Also, these look like perfect square trinomials, but they are not. If the last term is negative, it is not a perfect square trinomial because perfect squares are always positive. So watch out for these examples of unfactorable expressions. Use these notes as you continue with your homework. Thank you.